Okay, hello everybody. We're going to talk about 5.6 part 3 today. In part 2, we talked about the graph of cosecant. And in part 3, we're going to talk about the graph of secant. A lot of it is similar. It has some similar characteristics of the cosecant graph we did. But it also has a little bit or a few differences as well. So we'll talk about those. Remember that secant is the reciprocal of, correct, cosine. It's the reciprocal or flipped cosine. Okay? So first, in order to kind of see what the secant graph is going to look like, the flipped version of cosine, let's recall the cosine graph. Remember, for the cosine graph, the parent function, we have our normal increments, 0 to 2 pi, a max and min of 1 and negative 1. Remember, the sine graph starts at the origin at 0, but the cosine graph starts at its maximum up here at 1. So at 0 or 0 pi at 1, it's going to cross at pi over 2. It's going to hit its minimum at negative 1 at the next increment pi. Next increment, it crosses 3 pi over 2 back at 0. And finishes it where it started at 2 pi up here at 1. So the cosine graph, you've got curves down like this. And it comes down here, starts curving back up. A nice smooth cosine curve. All right, now, just like there were asymptotes, dotted vertical lines, asymptotes, undefined regions on the cosecant graph, there are the same on the secant graph. And it's where the cosine graph is equal to 0. These two spots. Where it crosses or where it's 0, that's where you're going to have two asymptotes. Or vertical dotted lines where nothing can exist, nothing can cross, nothing makes sense, nothing can be there. Okay? Now, notice how they are in different spots than the cosecant asymptotes were. The cosecant asymptotes were at 2 pi, pi in the axis. Well, these two asymptotes for secant are at pi over 2 and 3 pi over 2. So, let's go ahead and on the secant graph, let's put those asymptotes there. Oh, kind of missed that one there. That's okay. All right, now, if you look at the cosine graph, okay, we're just going to flip the parts of the graph to get the secant graph because cosine is the reciprocal or flipped version of, secant is the reciprocal or flipped version of cosine. So just like we flipped over the parts of the sine graph to get the cosecant graph, we're going to flip over these parts of the cosine graph to get the secant graph. But there's 3 parts we're going to flip. Sine graph, we just flip 2 parts to get the cosecant graph. We're going to have to flip this part, and this part separately, okay? So, if you take this curve right here, and you flip it up, it's going to kind of resemble or look like this, okay? So, first part down here in the secant graph, the parent function, the cosine curve goes like this. You flip it up. It's that kind of curve right there. You want an arrow, and it starts at the maximum 1. That's like the minimum for that curve. Okay? Now, we're going to flip this part down. Okay? So it's between the asymptotes. You still have a point at 1. That's kind of like your minimum point, but it's really a maximum for this parabola or curve. And you're going to have, that's your secant graph parabola between the asymptotes. And then pretty much the same thing over here. All right, the cosine graph goes like that, but we're flipping it up. It's going to kind of be like this at 2 pi. It's going to go like that. All right, so there is your parent function secant graph. It's a little funky looking because you have a full upside down parabola and you have two kind of half curves or half parabolas, but those are the three parts. And this could have different max and mins. It could shift up or down. It could shift left and right. We'll just keep it doing that for now. Keep it kind of simple, not too crazy and complicated. But we're going to go ahead and graph two variations of secant on the back, knowing what it kind of looks like now for the parent function. All right, so let's look at number one. All right, so we're going to graph this secant equation. We're going to graph one full period, and we're going to make sure we put the asymptotes, all right, and full points at our max and min, whatever they are. All right, so we got two things going on here. That 2 in front is going to change your max and min from 1 and -1 to 2 and -2. But then the -1 at the end is going to move everything, I'm sorry, not up 1, down 1. So this goes down 1 back to 1. This goes down 1 to -3. All right, so here we go. We're going to do our secant graph, but it's stretched out to 2, -2, but moved down 1, so our max and min. All right, so we can draw our axes. Max of 1. So there's our max of 1, min of -3, which really are our minimum and maximum of our curves, and nothing is going left and right, so we can put our normal increments up to 2 pi. Now remember, your asymptotes aren't at pi and 2 pi in the axis. They're at pi over 2 through pi over 2, and they stay there because nothing is shifted left and right. So our asymptotes are going to be like they are on the parent function because nothing is shifted left and right. All right, so we're going to pretty much graph this like the parent function, but we have our maximum points here for our individual curves. All right, so over here, the max is 1, so it starts at 1, but it goes up like we saw on the parent function. All right, we'll just go ahead and do this one over here. While we're at it, also at 1, and it curves up here. And then the center part between the asymptotes, the minimum -3, so a point right here, it's really the maximum though for the curve. And we have our upside down curve like such. All right guys, there's number one. And let's try one more secant graph for number 2. All right, here we have y equals the secant of quantity inside the parentheses x minus pi over 2, and then at the end plus 2. All right, so we got two things going on here. This is shifted to the right 1 increment. I remember we said on the notes in part 2, pi over 2 is 1 increment left and right. Pi is 2 increments left and right. 3 pi over 2, 3 increments left and right. And then at the end we have a plus 2, which moves our max and min up 2. All right, so our max and min aren't changed. No number over here. So our max and min stay right now at 1 and -1, but they each go up 2. Up 2 to 3 and up 2 to +1. So as well as the max and min being 3 and 1, everything goes to the right 1 increment. So our asymptotes will move to the right 1 increment. Okay. So we're ready to... Alright, so normally we would end at 2 pi, but everything is moved to the right 1 increment. So we're going to have to have a 2.5 pi, or you could call that 5 pi over 2, if you prefer. If you want, you can pick your asymptotes. Normal asymptotes would be at these 2 spots, but shifted to the right one. So we have an asymptote here and an asymptote here. All right, max and min of, so we need a 1, 2, 3. Here's where 4 would be. I'll put a -1 there. All right, now we're ready to get our curves. Now, let's start with our middle curve. Our middle curve is an upside down parabola between the asymptotes. And the point is at 1, minimum, or really the max for the curve at 1. So right here between the curves, and we have a curve like such. All right, on the side, these curves have points at 3. So normally it would be here, but we're shifted to the right one. So we're going to have a point here, and the curve, like we saw up here, goes like this next to the asymptote. And over here, at the very last increment, we have our point also at that point at 3, and the curve, this curve goes like that. And there you have it, number 2. All right, guys, that is how you graph secant equations. Thanks for bearing with me, and have a good rest of your day, rest of your week, and a good weekend as well. And I'll talk to you next week with those lessons. Bye-bye.